Hello, students. Welcome to our math class again. This moment, we're going to talk about solving quadratic equations by extracting square roots. Okay, first, we are going to find the square roots of the following. Number one, we have square root of 4 is 2 because 2 squared is 4. Next, the negative square root of 36 is negative 6. Next, we have the square root of 64 over 81 is equal to 8 over 9 because the square root of 64 is 8 and the square root of 81 is 9. Next is the positive and negative square root of 100 is positive and negative 10 because 10 squared or 10 times 10 is equal to 100 and negative 10 squared or negative 10 times negative 10 is also 100. And the last is the negative square root of 0.25 is negative 0.5. Okay, let's have the following examples. And we need to solve the following equations. Number one, we have x plus 4 equals 5. Our aim is to find the value of the variable x, or what number that we're going to replace x so that the given equation is correct. So we can apply SPE, or subtraction property of equality. So we need to subtract for both sides of the equation, the left and the right. So we have x plus 4 minus 4 equals 5 minus 4. So at the left side, we have already x because 4 minus 4 is 0, and at the right side is 1 because 5 minus 4 is 1. So the value of x is 1. We're going to check. We have 1 plus 4 is 5. So our solution is correct. X is equal to 1. Number 2, we have h minus 10 equals 3. Our aim is to find the value of h. So we will apply APE, or addition property of equality. So whatever number that we're going to add at the left side of the equation is the same number that we're going to add at the right side of the equation. So we need to add 10 both sides of the equation. We have h minus 10 plus 10 equals 3 plus 10. So at the left side of the equation is h because negative 10 plus 10 is 0. And at the right side of the equation is 13 because 3 plus 10 is 13. If we're going to check the equation, we will replace h with 13. So we have 13 minus 10 equals 3. So our solution is correct. Number 3, we have 2b is equal to 6, or 2 times b equals 6, because if a number and a variable is put together, that means you need to multiply. And we will apply DPE here. DPE is division property of equality. So whatever number you're going to divide at the left side of the equation is the same number that you're going to divide also at the right side of the equation. Since 2 is together with b, so we need to divide 2 both sides. So 2b divided by 2 equals 6 divided by 2. 2 divided by 2 is 1, so we have b at the left side of the equation, and 6 divided by 2 is 3. So the value of b is 3. If we're going to check the equation, we have 2 times the value of b, which is 3, is 6. So our solution is correct. Okay, number 4 example, we have 5 times y plus 1 equals 10. So we need to simplify first the left side of the equation. So we need to apply the distributive property so that we can solve this equation. Distribute 5 to y plus 1. So we have 5 times y is 5y. And 5 times positive 1 is positive 5. So we have here, at the left side of the equation, we have 5y plus 5 equals 10. Yes, we applied the distributive property. The next step is we need to apply the subtraction property of equality, or SPE. We need to subtract 5 both sides. So we have 5y plus 5 minus 5 equals 10 minus 5. So whatever number you're going to subtract at the left side of the equation is the same number that you're going to subtract at the right side of the equation. That's SPE, or subtraction property of equality. So we have 5y here at the left side of the equation because 5 minus 5 is 0. And at the right side is 5 because 10 minus 5 is 5. And we still need to apply another property of equality, and that's DPA, or division property of equality. Since 5 is together with variable y, so we need to divide 5 both sides. So 5y divided by 5 is y, because 5 divided by 5 is 1. And 5 divided by 5 is 1. So our solution is 1, or the value of y should be 1. If we are going to substitute that to the given equation to check if our solution is correct, so we have 5 times 1 plus 1 equals 10. And 1 plus 1 is 2, so 5 times 2 is 10. Therefore, our solution is correct. Okay, next. What is the root or solution for this equation? We have x squared is equal to 25. Or what will be the value of x there? And we have to, if we have to square it, the result is 25. So we will apply the extracting the square root for this. So we need to get the square root of the left side of the equation at the right side of the equation. So we have the square root of x squared is x, and the square root of 25 is positive and negative 5, because 5 squared or negative 5 squared is 25. Therefore, the solution is positive into negative 5. How about this? What is the root or solution? We have our equation, b squared equals 0. So what will be the value of t? That if we're going to square it, the result is 0. Okay, we will extract square root both sides. So the square root of b squared is d, and the square root of that is 0. 0 squared equals 0. So there is only one solution for this, which is 0. Okay, next. What is the root or solution for this? K squared equals negative 4. If we will apply the extracting the square root, both sides, we have the square root of k squared equal to the square root of negative 4. My question is, can you find a solution for this equation? Can you find any number that you are going to substitute to k, and if you are going to square it, the result is negative 4. What's your answer? There is no solution. None, because you can find two identical numbers, either two positive or two negative real numbers, that if you're going to multiply, the product is negative 4. So you have to take note of this. Rules. Quadratic equations that can be written in the form x squared equals k can be solved by applying the following properties. So there are 3 properties that we are going to take note. Number 1, if k is greater than 0, meaning what are those numbers greater than 0? All those positive numbers, from positive 1 to positive infinity. Then x squared equals k has 2 real solutions or roots. It's either positive or negative root. Like our first example, x squared equals 25. Our solutions or roots are positive and negative 5. So just take note, if k is greater than 0, or the number that is written at the right side of the equation is greater than 0, then it has 2 real solutions. It's either positive or negative. Number 2, if k is equal to 0, then x squared equals k has 1 real solution or root, and that is 0. So you have to take note, if 0 is at the right side of the equation, there is only 1 real solution, that is 0. And the third, if k is less than 0, what are those numbers that less than 0? We have those negative numbers, from negative 1 to negative infinity. Then x squared equals k has no real solutions or roots. Like our last example, we have k squared equals negative 4. We cannot find any real solutions or roots for that, because negative 4 is less than 0. So you have to take note of these 3 properties, that if we are going to check if the given quadratic equation is written in the form x squared equals k. To sum up, the lesson was about solving quadratic equations by extracting square roots. The lesson provided you with opportunities to describe quadratic equations and solve this by extracting square roots. You were also able to find out how such equations are illustrated in real life. Moreover, you were given the chance to demonstrate your understanding of the lesson by doing a practical task. Your understanding of this lesson and other previously learned mathematics concepts and principles will enable you to learn about the wide applications of quadratic equations in real life. Don't forget, like quadratic equations, there is root or solution. If we have some problems in life, we should put in mind that there is always a solution for it. God is always there, ever willing to help in solving all our problems. Remember in Jeremiah 33:3, call unto me, and I will answer thee and show thee great and mighty things which thou knowest not. That's all for today. I hope you learned something about solving quadratic equations by extracting the square roots.